Welcome everyone to today's tutorial. Today we are going to be working on solving systems of linear equation. I'll be using the determinant method to solve them. So we have a question here. This is a system of equation. Equation 1, equation 2, and equation 3. And each of these equations has three variables: x, y, and z. So we'll start by deriving our matrix A from that system of linear equation, and this will form a 3 by 3 matrix. So first I'll pick out the coefficient of each variables here. So I have on my first row I have 2 minus 3 minus 1, which is the minus 1 is the coefficient of z, as we know. Then in my second row I have 1, 1, and 1. Then my last row I have the coefficient 3, 2, and minus 4. So that's just what I need for matrix A. And then I'll have a separate column matrix for my variables that I'm asked to find the solution of x, y, and z. And then the last matrix I'll form, I'm going to call that y. This will be the column matrix of the numbers I have on the right hand side of the equation: minus 1, 2, and minus 27. Okay, now when it comes in solving systems of linear equations in the determinant method, one thing we should know is that we use determinants to compute each of the augmented matrices that are gotten by replacing each of these columns successively with our y matrix. So by the time I finish this example, we'll have a clearer understanding of what I mean. So first, I'm going to get the determinant of my original matrix A. Okay, and the formula or the method we use to get the matrix, the determinant of a matrix, particularly in this case a 3 by 3 matrix, is that we are going to get the cofactor of this first row, the elements in this first row. So I'm going to start with this 2 by deleting the element in the row, in the column of 2, and the elements in the row of 2. So I'll pick out this 2 here, and then I'm left with this other element, which I'll put in the box: 1, 1, 2, negative 4. And don't forget to include your alternating signs. It's always start with the plus. It alternates through from plus, negative, plus, and so on. So the next number I have here is 3. Let me wipe this off. So I have 3 here. So I'll eliminate all the elements in the row of the second element in the first row, and then all the elements in the column. So I'm going to pick minus 3. Whatever I have there, that's what I'll use to avoid mistakes at the end. So I have minus and then minus 3, because that's the number, or that's the coefficient of y in the first row. And then I'll write down the elements I'm left with. 1, 1, 3, minus 4. Okay, so over to -1 now, but this time there's a plus in front of it. So I have plus minus 1. I'll delete all these and these. So I'm left with 1, 1, 3, 2. The next thing I will do is to take the determinant of each of these, the way we do a normal 2 by 2 matrix. Okay. So my 2 will be outside the bracket, and then I'll multiply the elements. Take note, this is -4. I'll multiply the elements in the principal diagonal. 1 times -4 is -4. And then I'll multiply the elements in the secondary diagonal, subtract it from the elements, the product of the elements in the principal diagonal. So I'm going to put my minus 2 times 1 is 2. Minus times minus is plus. Then 3, multiplying the elements in my principal diagonal. 1 times -4 is -4. And then removing the products of the elements in my secondary diagonal. 3 times 1 is 3. Plus times minus is minus. I bring down the 1. I have the brackets. 1 times 2 is 2, minus 3 times 1 is 3. Alright, so let me go ahead to compute my result. So this will be 2 minus 4 minus 2 is minus 6, plus 3 minus 4 minus 3 is minus 7, minus 1. 2 minus 3 is minus 1. So this will be 2 times -6 is -12. 3 times -7 is -21. And minus 1 times minus 1 is +1. So minus 12 minus 21, that's -33, plus 1 is -32. So this is my determinant of A. I haven't computed the determinant of my original matrix A. I'll move over to start augmenting my A matrix and my Y matrix. And when I augment them, that is when I replace a particular column with my Y column, I'm going to get a matrix. So I'll start by replacing this first column here with this. I'll call that A1. So this is the augmenting process. So I'll have -1 to -27. I just replaced this column with Y, and then the rest will remain the same. -3, -1, 1, 1, 2, and -4. And then I'll find the determinant. So I will quickly do this to save time. So beginning with -1, I'm putting up my signs here, which will help me. I can simply take this out. already got what I want, so to make the place look more better, so this plus at the top. Alright, so I'll cancel these and these. 1, 1, 2, -4. Okay. And for the next, cancel out these. These I have -3, 2, 1, -27, and -4. Last element here, which is -1 plus times minus is still minus, so you can go ahead to write it that way. So I'm getting my determinant now. Remember, there is always a minus in the formula. Then minus 27 times 1 is -27, minus 1. Okay, 2 times 2 is minus, then my -27 times 1 is -27. So this will be equal to -1, -4, -4, -2 is -6, plus 3, minus 8, plus 27, 19, minus 1, 4 plus 27, because minus is positive, so 4 plus 27 is 31. Okay, so -1 times -6, please, this is 1. This +6 plus 3 times 19 is 57, minus 31, so this is 32 for an answer. Then I'll go back to get the determinant of the second augmented matrix. Now I'm through with first step. I'll move back to the second column. Place this column with my Y matrix. So I have A2, determinant of A2 equal to 2, 1, 3, minus 1, 2, -27, minus 1, 1, -4. Let me quickly take out all this. Of course, we know that my A1 gave me positive 32. So I'm just going to put it here. A1 gave me, okay, yes, a positive 32. And then I can continue with my A2 to get the determinant of my A2. So I have this will be equal to, taking this first element, so I have 2, deleting this and this, so I have 2, 1, -27 and -4, Then for the second one, second element, in the first two, that's -1, -1, 1, 3, 1, -4. Then the last one here, which is 1, has a plus in front of it. Sign attached to this, a plus ball. I think the main number is a -1 as well. This is a -1 from the original matrix. In this case, this is a -1, so I'm not replacing that third row, that third column rather. So I have plus, this plus times this minus is plus, is minus rather, -1, then have 1, 2, 3, -27. Alright, so I'm going to get a determinant. So times -4 is -8 minus -27 times 1 is -27. And then minus minus is +1. 1 times -4 is -4. Then 3 times 1 is 3. I always put minus in the middle to get the final results. Then -1 comes here. 1 times -27, -27 minus 3 times 2, 6. Okay, this will give us 2 times -8. This minus minus is plus, so -8 plus 7 is 19. Then plus 1, -4, -3, -7, minus 1, -27, -6 is -33. So 2 times 19 is 38. 1 times -7 is -7. Minus 1 times -3 is -1 times -3 is +3. So this will add up to 64. Therefore, 82. This one is for A1. 82 is equal to 64 positive numbers. Alright. So I can just go ahead to delete all these ones. And then you can take the rest up. So I've got my A1 and A2. The next I'm going to do is to get my A3. So my A3, determinant of my A3 will be to replace this third column with my Y matrix. So this will be equal to 2, 1, 3 minus 3, 1, 2, -1, 2, minus 27. This is equal to, so I'll start with 2 brackets. Okay, let me do it one after the other to avoid mistakes. 1, 2, 2, negative 27. Then for the next one, minus 3, minus 3. 1, 2, 3, negative 27. And for the last element here, plus negative 1, that's still negative 1. 1, 1, 3, 2. Okay. So this will be equal to 2 times. Okay, I'll start with my principal diagonal, which is this side. 1 times negative 27 is negative 27. Minus 2 times 2 is 4. Plus 3, negative 27 minus 6, minus 1, 2 minus 3. So this is 2, negative 27, negative 4, that's negative 31, plus 3, negative 33, minus 1, minus 1. So by the time I'll add all this together, I'm going to have negative 160. Multiplying these expressions and adding them together will result to this answer, negative 160, and that gives me my determinant for the third augmented matrix A2, negative 160. Now the last step to finish on this question is to get the solution x, y, and z. I'm going to get the solution of x, y, and z. So x will simply be the first determinant of the augmented matrix all over the determinant of matrix A. Solution for y will be the determinant of the second augmented matrix all over the determinant of A, and z will be my third augmented matrix, its determinant all over the determinant of matrix A. So my first augmented matrix was 32 all over my original matrix. Take notes, it's negative 32. So negative 32 plus divided by minus is minus. 32 divided by 32 is 1. My y will be equal to, okay, I can write it down here. My y will be equal to positive 64 divided by the original matrix, which is negative 32. That's equal to negative 2. In my last augmented matrix, negative 160 all over negative 32, negative cancels out. So z is equal to 5. Therefore, solutions for this equation, my x, y, and z, my x is equal to, I had negative 1, my y is equal to -2 and my z is equal to 5. You can check if you are correct by the time you substitute each of these values into any of this equation, and you have the value on the right hand side that tells you are correct, like the second equation, x plus y plus equals to 12. So if I substitute it, if I say -1 plus -2 plus 5, because we know -1 minus 2 is -3, and -3 plus 5, which is here. So that's how we can solve a system of linear equations using determinant method. Thanks for watching. God bless you.